related rates. In this section, we will consider problems involving two or more variables that are changing with respect to time t. In such problems, we want to find the rate at which some quantity is changing by relating it to other quantities whose rate of change are known. If two such quantities are related to each other, then the rates of change with respect to time t are also related. Here are the examples. A tank of water in the shape of a cone is leaking water at a constant rate of 2 cubic feet per hour. The base radius of the tank is 5 feet and the height of the tank is 14 feet. At what rate is the depth of the water in the tank changing when the depth of the water is 6 feet? Okay, we should probably start off with a quick sketch of what is going on here. So, this is the cone. As we can see, the water in the tank actually forms a smaller cone with the same central angle as the tank itself. So, the radius of the water cone at any time is given by r, and the height of the water cone at any time is given by h. So this is our r, and this height will be our h. So it's given that the radius of the tank is 5 and the height of the cone is 14. So the volume of water in the tank at any time is given by volume is equal to 1/3 pi r squared h. To fix this, we'll need to eliminate the r from the volume formula in some way. This is actually easier than it might at first look. If we go back to our sketch above and look at just the right half of the tank, this one, we see that we have two similar triangles. This triangle and the big triangle. And when we say similar, we mean similar in the geometric sense. Recall that two triangles are called similar if their angles are identical, which is the case here. When we have two similar triangles, then ratios of any two sides will be equal. For our set, this means that we have r over h is equal to 5, our radius of the tank, and the height of the tank is 14. So we need to find r. So r is equal to 5 over 14h. If we take this and plug it into our volume formula, we have V is equal to 1/3 pi r squared h. So 1/3 pi. It is given that our r is 5 over 14h. We need to plug in this radius. So we have 5 over 14h square times h. So we have now the 1/3 pi 25 588 h cubed. So this gives us a volume formula that only involve the volume and the height of the water. So we need to get or to derive the height, the volume in terms of the height. So we have dv dh is equal to 1/3 pi 25 588 h cubed. So derive it, we have 3 1/3 pi 25 588 h squared. So we have now the volume in terms of h, 25 pi h squared over 588 dh dt. So we are asked to find the rate or the height of the water in the tank changing when the depth of the water is 6 feet. So in the problem, it was stated that the cone is leaking at a constant rate of 2 cubic feet per hour. So we have -2 is equal to 25 over 588 pi h squared times dh dt. So we have 25 588 pi, the height or the depth of the water is 6 feet dh dt. So we have the answer of so our dh dt is -98 over 75 pi over dh dt. So it looks like the height is decreasing at a rate of -98 over 75 pi.
Water is flowing into a vertical cylinder tank at the rate of 24 feet cubed per minute. If the radius of the tank is 4 feet, how fast is the surface rate?
First, we draw a cylinder. This is a cylindrical tank. Then, the water. This is the height of our water. Then, since we have a radius 4 feet. Okay. Then, since our given is, we have a radius equal to 4 feet. Then, our 24 feet cube per minute This is a rate at which the water is flowing. This is our dV dt. We all know that our volume is 16 pi times the height. And then our unknown is dH dt, where dH dt is a rate which the water level is rising. Okay. Our dV dt is with respect to time 16 pi our dH dt. We all know that our dV dt is equivalent to 24. Our dV dt is equivalent to 24 feet cubed per minute. It's equal to 16 pi our dH dt. Then we multiply both 1 over 16 pi and then cancel our 16 pi. Also our right side, or the left side rather, 16 pi. Okay. And then dH dt. We multiply 24 feet cubed per minute over 16 pi. Then our dH dt is equivalent to 0.477 feet per minute, or 3/2 pi feet per minute. This is our dH dt. This is the rate at which the water level is rising.
Pangarap parang kailan lang sa panaginip ko'y nakita. Ngayon ay dumating nang bigla sa aking buhay, di naubusan ng pag-asa.